Okay, today we're going to talk about how you can use basic facts and patterns to multiply by a two-digit number. Have you multiplied by a two-digit number before? Like 120 times 23? Okay, so we're going to talk about how we can maybe break that down a little bit so it can make it easier for us. How close have you ever been to a bumblebee? Too close sometimes, huh? The actual length of a queen bumblebee is about 20 millimeters. The photograph shows part of the bee under a microscope at 10 times its actual size. What would the length of the bee appear to be at a magnification of 300 times its actual size? So this is 10 times its actual size. What would it be at 3 times its actual size? Well, we can say, remember they said the bumblebee was 20 milliliters. We can take our 3 and our 2. That's a basic fact, right? Easy. You learned that a long time ago. What is 3 times 2? 6. Then we can add a 0, because we're taking it times 30. So we still have our basic fact of 3 times 2. And then we're going to multiply it times 10 to the first power. We're going to multiply it by 10 because the 3 here got multiplied by 10, right? Then we're going to multiply it by the second power of 10. And so then we have 3 times 2 times 10 to the second power of 10 because we're magnifying it 300 times. So we're magnifying it with our 10 to the second power of 10, that's 100. So 3 times 2 is 6 times 100 times 10 . And then so we have 2 times 3 is 6 and 100 times 10 is the third power of 10. So this was 600, and what is this? 6,000. We went up another power of 10, so it is 6,000 millimeters. So right here, we had 100 because we had to multiply 3 times 100. And then we added our 10, multiplying our 2 by 10. So that's how we get the 3. What would the length of the bee shown in the photograph appear to be if the microscope shows itself at 10 times? So we're going to have, it's 20 milliliters long, and we're going to multiply it by 10. So what is 2 times 1? There's our basic fact. Times 10 to the power, first power here, and the second power here. So we're going to have 10 to the second power. So 2 times 1 is 2 times 10 to the second power. What is 10 to the second power? 10 times 10. So 2 times 100 is 200. Okay, so now we're looking at 50 times 8,000. All right, so now 5 times 8 is 40, and 10 times 1,000 is 10,000, right? So now we have 40. And then we should have 1, 2, 3, 4 more zeros for our exponent. So to multiply 50 times 8,000 is 400,000. says use mental math and a pattern to find the product of 30 times 4,000. Well, what is 3 times 4? 12. How many zeros do I have in the 30? How many zeros do I have in the 4,000? Everybody understand that? 120,000. What basic fact can you use to help you? So what basic fact did we use? 3 times 4 equals 12. So then we went 12 times 10 for our 30 times how many? 1, 2, 3. 10 to the third. And this equals 10,000. And then we've got to say 12 times 10,000. Okay, I want you to stop. I'm going to stop the recording. I want you to do 3 and 4. If you're at home watching, do 3 and 4. Okay, so we know that 7 times 8 is 56. And what's our exponent? 1. So how many zeros are we going to add? 1. And 56 times 10 is 560. Again, we know that 7 times 8 is 56. And we know that 10 times 10 is 100. So we're going to add 2 zeros to that. We know that 7 times 8 is 56. We know that 10 times 10 is 100 times 10 is 1,000. So we're going to add 3 zeros to that. Now they gave us our basic fact here, which the answer is 30. And then we had to figure out what the power of 10 is. Now remember, we are looking, we have 2 zeros in our answer. Right? But one of them is this. So this is 10 to the first power of 10. This is 30. So one of these is this. So this is the, this is the second power of 10. And then again, we would have 30. So one of these would go away. So this is 10 to the third power. Okay, so 5 times 4 is 20. So 5 times that. So here we have 2 zeros. One of those zeros is from the 20. So what power of 10 did we multiply by here? First power. Again, we have our 20. So we have that 1 zero, how many? 2. And here again, we have our 20. So one of these is gone, so we have to the third power. Oops. Okay. This is number 9. 2 times 4 is 8. Now on this one, there is no zero in our basic fact, right? So the only zeros we have to account for are those in our exponent. So the only thing that can really be tricky about this is if when you multiply, like in this one, 2 times 5, and you get 10, you still have to remember to add 3 zeros. And in this one, when you get 30, you have to remember to add 3 zeros. So this is on the very bottom where it says use mental math. This is 11, circle these, 11, 13, 15, 17, and 19. So you should have circled all the odd ones. 11, 13, 15, 17, and 19. I'm going to give you a few minutes to do it. Here we go. What was 6 times 6? And how many zeros? What is 9 times 8? And how many zeros? And what is 2 times 5? And how many more zeros? And what is 6 times 5? And how many more zeros? And 7 times 8? And how many more zeros? Good job. All right, this is on your own. This is on the top of page 23. Okay? 1 roll equals 50 dimes. Remember that. 1 roll equals 50 dimes. That's going to be important. It says think 50 dimes per roll times 20 rolls. Okay? So we have 20 rolls. 10 dimes are how much? 10 cents. And 10 to the second power. Okay, so 10 to the second power. 1, 2. All right, so what would 30 times 50 dimes be? What's 3 times 5? 15. And we're still going to do 10 to the second power. So that's what you should write under 30. Now what if we do 40? So what's 40 times 50? Or 4 times 5? 20. Is it really going to be 20 in there? Yep. Times 10 to the... And 5 times 2 is? No, I'm sorry, 5 times 5. 25 times 10 to the second power. 6 times 5 is? Times 10 to the second power. 5 times 7 is? Times 10 to the second power. 8 times 5 is? Times 10 to the second power. And 9 times 5 is? 45 times 10 to the second power. And then 100. 1 times 5 is 5 times 10 to the what? Third power. Or you could say 50 times 10 to the second power. That is. All right. This is the problem solving down at the bottom. Arthropod lengths. Use the table to solve the problem. What if you magnify the image of a cluster by 9 times 10 to the cluster fly by 9 times 10 to the third power? What would the length appear to be? So what is 9? The cluster by 9 times 10 to the third power. 9 times 9 is
81.
81, and then if we're going to take it to the third power, it'd be 81,000. What is it in? Millimeters. If you magnify the image of a fire ant by 4 times 10 to the third power and a tree hopper by 3 times 10, which insect would appear longer? Okay, so how long is the fire ant? 4. And we're multiplying 4 times 4 times 10 to the third power. So what is 4 times 4?
60.
To the third power. And what other thing were they doing? The tree hopper. How long is the tree hopper? 6 times. And the tree hopper times 3 times 10 to the third power. So 6 times 3 is